You can refer to uLearn for the email IDs. Because we don't have a compulsory session for tutorial, only for lectures. So you can practice the tutorial questions just for practice by referring to the notes. So today we have to complete the unfinished one. Yeah? We haven't done this, so we have to finish this part, and then we will move on. Yeah? So, please bear with me. Just wait for a while. Okay, class. So we will start now. Okay, good morning, class. So today, please refer to 3.3 later on, slide number 13, under translation theorem. Yeah. So this is we haven't finished yet. Translation theorem. This part we missed it because the notes was uploaded later. So you please check this translation theorem. Of course, from slide 1 to slide 12 is the first translation theorem. Now we want to look into second translation theorem. So translation theorem we already done. So you have to check the slide 1 to slide 12. Now the unit step function, or we call it Heaviside function. Heaviside is the name of the person, is defined in this form. So this is unit step function. Ut minus a is defined like this. So this is the definition. We have to take note here. You see this U, capital U, stand for unit step function. U t minus c equals to 0 when t runs from 0 to a. This is the x-axis, yeah, t. And t not equals to a. That's why it is open hole. This one is closed hole, shaded, because this is t greater than a equals to 1. This one is y-axis, capital U. When t equals to a, t equals to a, this become 1. This one, straight line, horizontal line. From when t equals to 0, this is 0. T equals to 0 is 0. T equals to a, 1. So this a must be same as this a. Take note, yeah. This is the basic definition. You cannot change this. Only we can change the value a. A I can put, for example, 5. So 0 to 5. And then greater than 5, 1. So that's why we call it unit. The word unit step function, ut minus a, is defined like this. Now, what is Laplace? So, you know, Laplace of ft is fs. You have to refer to the 3.1 and then 3.2. Now we are in 3.3. So Laplace of ft is capital Fs. Now, if capital Fs is Laplace of ft and a greater than 0, then Laplace of ft minus a. This ft now becomes ft minus a of ut minus a. This t minus a must be same as this. Otherwise cannot. So Laplace of ft minus a of ut minus a equals to e power as fs. What is fs? Fs is Laplace of ft, this one. But here there is ft minus a. It doesn't mean that Laplace of f multiplied by Laplace of u. No, it's not like that. Because this one is defined. Okay, this is the theorem, yeah? Second translation theorem. You must refer to first translation theorem. This one is second translation theorem, which involve the unit step function. So Laplace of ft minus a ut minus a equals to e power minus a as fs. But Laplace of ut minus a is eas divided by s. Because this ft minus a, ut minus a is 0 and 1. 0 and 1. So 0, no value. So if you look at the Laplace of t power 0 is 1 over s. If you refer to the table in chapter 3, chapter 2, the formula for Laplace. You can refer to formula for Laplace, chapter 3.1, yeah. Under 3.1, we have to refer. Otherwise cannot. So 3.1, Laplace of 1 is 1 over s. Laplace of 1 is 1 over s. 3.1, slide number 18. If you have any question, you can ask me. So this definition is Laplace for ut minus a equals to e over as over s. Now, using this formula, we want to find Laplace of this. Laplace of t minus 2 power 3 u t minus 2. So this A, all same. So A is 2. Because this one you must match with the theorem. The theorem is this one. Yeah? So we are using this one. Laplace ft minus a ut minus a equals to e power as fs. So we are using this formula to solve this problem. Now the thing is, you must modify this according to this one. So ft minus 2 t minus ft minus 2, this one, the whole thing is equals to watch carefully here, t minus 2 power 3. The whole thing ft minus a is 2. A is 2, this one. So ft minus 2 equals to t minus 2 cube. But what in Laplace, we want ft only. Because this fs is Laplace of ft. You have to go back this. This one comes from here. Of course, first you have to match this. First you match this. Then if ft minus 2, t minus 2 cube, the t minus 2, you must make it t. So the t minus 2, you make it as t. Because this is t minus 2. It's just like you substitute t minus 2 with, for example, r. So fr, r cube. So if ft minus 2, t minus 2 power 3, I can replace this t minus 2 with t. Because then I can use the formula from the table 3.1, slide number 18. Using Laplace of Tn, t power n is n factorial divided by Sn plus 1. That's why we have to make it like this. So now Laplace of t minus 2 cube ut minus 2 equals to e power minus 2s. So your a is 2. And this fs is Laplace of t cube, this one. Because in the table, you have Laplace of t cube, not Laplace of t minus 2 cube. If t minus 2 cube, you have to expand this. No, that will be a very long way. So you want to just change t minus 2 into t. So Laplace of t cube, you have the formula n factorial divided by Sn plus 1. So n is 3. So 3 factorial divided by s power 3 plus 1. So 3 plus 1 is 4. Now 3 factorial is 3 multiplied 2 multiplied 1, 6. So 6 e power 2s divided by s power 4. This is your answer. Now we are making use of unit step function, this formula, and then Laplace of t power n. Laplace of t power n, you must refer to table 3.1, slide number 18. Any question, class? Yes, Chair. Any question in this example 6? Wang Chen, Wen Kan, Yong, I'm waiting for you. Any question, class? Any question on example 6? Thank you, Wong. Okay, so we proceed, yeah? So we proceed. Example 7. Example 7, your FT, this is step function, 3 pieces. Laplace of FT, 2 minus 3 ut minus 2 plus ut minus 3. This formula is already fixed. Laplace of ut minus a equals to e power as os. This formula is given. You cannot change this. This one. Write down, yeah? This one, Laplace of ut minus a. This is theorem, yeah? Very strong theorem, yeah? You cannot change the theorem. Like Pythagorean theorem. You cannot change the Pythagorean theorem. So, Laplace of ut minus a is e power as os. You may ask, is this formula will be given or not given? Or how we is the way we can memorize it? Of course, it's very hard for you to memorize, but normally these formulas is available in the form of table. So you will be given a table with all the information. So you just have to refer the unit step function with the formula. So now there are 3 pieces: Laplace of 2, Laplace of 3 ut minus 2, Laplace of ut minus 3. So Laplace of ft, because you want to find Laplace. So this Laplace of ft, you have to decompose. So you have to open up. This is what we call the distributive law. So Laplace of 2 here, and these 3 you take out, minus 3, and then Laplace of ut minus 2 plus Laplace of ut minus 3. This is step number 1. Step number 2, Laplace of 2. Laplace of 2, you refer to 3.1 under the title Transform of Some Basic Function, slide number 18. Laplace of 1 is 1 over s. That is the formula. Laplace of 1 is 1 over s. So Laplace of 2 is 2 over s. You can take out 2 and then write Laplace of 1. So answer is still 2 over s. Minus 3, you take out minus 3. Laplace of ut minus 2, straight away you apply this formula. You substitute a is 2. So e power minus 2s divided by s. And then Laplace of ut minus 3, again you must use this formula. Laplace of ut minus a is 3, so e power minus 3s os. Now you simplify this. So actually we are finding Laplace of ft. Later on we have to find inverse Laplace. So in order to find inverse Laplace, you must know Laplace first. That's why you are studying this. But the table is very important. Table is very important. 3.1, write down here, 3.1 Laplace transform, subtopic transform of some basic function. There are 7 functions. Number 1 is Laplace of 1 equals to 1 over s. Number 7, Laplace of cosh kt. Cosh kt. Cosh, C-O-S-H. Cosh kt s over s squared minus k squared. That is formula number 7. This formula, if possible, you memorize it. It will be good for you. If you are not good in memorizing these formulas, please refer to this very frequently. Now we move on. We move on. Example 8. In any point, you can stop me. Now, this one is not like factorization or multiplication, because this is unit function, unit step function. You must use, if you want to find Laplace of this GT, you must use this formula. That's why they always quote this formula. We cannot use 2t multiplied by t, 2t minus 1. No, cannot. Because this one is not a normal equation like in algebra. This is a unit step function. So the way how to handle this type is using this formula. We have to quote this formula. Laplace of ft minus a ut minus a equals to e power minus as fs. Now Laplace of dt is Laplace of 2t minus 3 ut minus 1. Now this one is equals to this, and ut minus 1 equals to this. So in this case, your a here is this a. This is a. This one we have to look into later how we can expand this. So Laplace of ft minus a ut of t minus a is EAS fs. So Laplace, because this a is 1, so this a is 1. So e power s Laplace of 2t minus 1. So this one you have to make it ft minus a. So t minus a, 2t minus 3. So you have Laplace of 2t minus 1. So Laplace of 2, this one you can use what we call this distributive law. You can Laplace of a plus b is Laplace of a plus Laplace of b. So just now we did this one, right? ft minus 2 t minus 2 power 3. So ft is t power 3. So similarly, if you do like that, you will get this Laplace 2t minus 1. You have to do this one. You have to make it this way using this formula. Still, you can use the 2t. But in this case, they are using a different way because this is the easiest way to calculate. So Laplace of 2t minus Laplace of 1. Laplace of 2t, you use the formula 3.1. Laplace of 2t is 2 over Laplace of t power 1. So 1 factorial divided by s, 1 plus 1, 2. So this is s power 2. Minus Laplace of 1 is 1 over s. So class, the 2t, you must write 2t minus 2 minus 1. So it becomes 2t minus 1 minus 1. So this is equals to 2t minus 3. So 2t minus 1. So 2t minus 2 minus 1. So you take out 2t minus 1. So that's why t minus 1 become t. So 2t minus 1. So you modify this. This one is minus 3. So minus 2 minus 1. Like this, yeah. Here. This one is very easy. But here is different. So you modify this. 2, write down here, 2t minus 2 minus 1. But 2, take out 2, t minus 1, minus 1. So the t minus 1, you make it as t. Then this become 2t minus 1. Okay, write down here. The ft minus a is equivalent to 2t minus 3. But this t minus a, you write 2t minus 2 minus 1. And then you take out 2 factorize 2 in the bracket t minus 1 minus 1. And then you take t minus 1 as t, because the a is 1. And this a is 1. This a must be the same. So 2 multiplied by t minus 1 minus 1. And then t minus 1, you make it as t. So you have 2t minus 1. So the t minus 1 is t. Now, after you make this, then these 2 actually you can take out. 2 Laplace of t, 1 over s squared, minus Laplace of 1 over s. That is the difficult part. This one is equals to this. So you have to modify. That's why this becomes 2t minus 1. They already skipped one step. So you rewrite again, 2t minus 3 equals to 2t minus 2 minus 1. And then take out 2 in the bracket t minus 1, minus 1. After that, the t minus 1 becomes t, like this. Like this. T minus 2 becomes t, like this. But this is one term only. But here got 2 terms. Sorry. Here got 2 terms, minus 1. So that's why. Okay, take your time. You can revise this later. Now, this translation theorem, if you compare the translation theorem here, example here, this one is a standard unit step function, 0 and 1. It's very easy. But we also have more complicated one. That is G and H. So this one, 0 and 1. Now you compare this one. This one is G, T, and this is HT. 0 to A, T greater than A. So that means you have 2 different functions. 0 to A, let's say one function, gt, and then t greater than A, let's say this is your A, this is your A, greater than A, it's another function, ht, like this. So unit step function can be used to write piecewise. The keyword here is piecewise defined function in a compact form. What is compact form? compact form is this one. So you want to write ft in a compact form. So how do we do that? This ft is piecewise. This is what we call piecewise, two pieces. ft equals to gt, t0 to a. And then t greater than a is ht. So now this compact form is already designed like this. So you no need to change. ft, first one is plus. First one is plus gt. This gt you put it here. Minus gt ut minus a. So the gt again here, but there is minus sign, gt u t minus a. So this is your a. This is plus, minus, and then plus ht, put it here. The unit step function u t minus a. This a goes here. So this, you must memorize this, or you can refer to this anytime when there is a question on Laplace transform. So what we are going to do now is, we want to find Laplace of ft. So let us say this is example, yeah, defined like this, three pieces, right? ft equals 0 from t0 to a. So that means 0 to a, one function. This is 0 to a is 0, and then a to b is one function like this. Let's say from a to b. So this is your b. Okay. So this one is the vertical line. So 0 to a is 0. And then from a to b, this is your gt, it's another function. It can be a horizontal line or any curve also possible. So I put here horizontal, easy to see. So for this, because this 0, so we don't have anything here. No need to write gt. So the compact form ft, you write with plus. Always start with plus. Since this is gt is 0, nothing here, but you start with positive because this one is nothing here. So you start with positive gt u t minus a. So actually this a same. So you put it here. And then this is plus, minus, because this is 0, so there is nothing here, minus u t minus b. Because for t greater than p, t equals to p is a unit step function because there is no ht here. So we just leave it as a unit here, plus, minus. So this is compact form for the piecewise defined function. So there is one step before you find Laplace. There is one step where we have to what we call construct the compact form first, because we cannot straight away find Laplace of ft from here. That also possible, but then it will be a shortcut. So you bypass this. That is up to you, right? So using this piecewise defined function, you create compact form. So the good thing about compact form is you can find the Laplace. So look at example 9 carefully. So Laplace of ft. But ft is defined two pieces only, 0 to 3. 0 to 3 is a straight line, ft, this is 3. Greater than 3, this is 2. This is 2, like that. This one is like this. So, ft equals t, like y over x, straight, this line. And then this is 0 to 3. Greater than 3 is 2. Of course, you can use the original definition for the Laplace, because Laplace defined from 0 to infinite. So for this piecewise, 0 to 3 plus 3 to infinite, using the formula E minus ST FT dt, the chapter 1, chapter 3, 3.1. But we are not going to use that, because this is, you are not going to use the original equation, formula. It's another way of doing. We can call it this as a shortcut as well, because you are not going to use the original definition of Laplace of ft. So that is the one we can call it advantage, or this is a shorter way to find. Now you must write this in the compact form. So here ft equals to gt, t 0 to a. When t equals to 0, this is 0. T is 0. T greater equals to a. This is 3. So now ft equals to gt minus gt ut minus a plus ht ut minus a. So this is the form, compact form. Now you fill up. You fill up the values. So ft is t 0 to 3, ft to t greater than 3. So what is your a? A is 3. So this is 3. So this is a is 3, and gt is t, ht is 2. So you match this one, ht, and then this is gt, then this is gt, this is a, this is a is 3. So now you construct your ft using this formula. Directly, this is ft equals to gt equals to t minus gt t u t minus a, 3, and then plus 2. ht is 2, so you put 2 here, and then u t minus a. After this, then you find the Laplace. Laplace of t ut minus 3 plus Laplace of 2 ut minus 3. This one you must be careful, because this one we must use the formula. This one we must use the formula. So the formula, you have to go back to the previous slides. This formula, right? F t minus a, u t minus a, EAS, Fs. So you must use that formula for this part. So this one we do it in a different way. You see it's the next slide. Laplace of ft. So you take out Laplace of ft one by one, yeah? Laplace of t, Laplace of t u t minus 3 plus, of course, Laplace of 2 ut minus 3. They already taken out 2 Laplace of ut minus 3. This formula is for Laplace of the unit step function ut minus a equals to e power minus as over s. But Laplace of t, you can use the formula from 3.1. Formula 3.1, you already have the Laplace of, from the table, yeah? Laplace of, I'm referring to the table, Laplace of t power n. So Laplace of t power n is n factorial Sn plus 1. So n is 1, 1 factorial 1, s power 1 plus 1, 2. But Laplace of ut minus 3, we have to do some modification because this one ut minus 3, but here only t. So we have to make it ft minus 3. So we leave aside first. We look into this later in the next slide. But this one, 2 of Laplace ut minus 3, directly use this formula, e power minus 3s over s. So we already finished Laplace of t, to Laplace of 2 ut minus 3. But this one, Laplace of t ut minus 3, not yet. So for this, you have to do in this way. Laplace of t ut minus 3, we have to use this formula. Formula is clear. Laplace of ft minus a, ut minus a equals to e power minus as fs. Since your a is 3, this ft minus 3, this ft minus 3, you force this equals to t. Because you are matching. This t is ft minus a, but a is 3. Same as what I told you just now, you have to modify this. This is very important, class. This is the real catch. Otherwise, your answer will be different. So now, ft minus 3 equals t, but what we need is ft, because this is Laplace of ft, not ft minus 3. ft minus 3, you just fit into the formula. But after that, this t must be, this t minus 3 becomes t. T minus 3 is t. Therefore, this t is t plus 3. Because this t minus 3, you make it as t. That means I plus 3 here. I add 3 here. T minus 3 plus 3, then it becomes t. Then this t minus 3 becomes t. If t minus 3 becomes t, then the t must be t plus 3. So these two are balanced, just shifting. This also, we call this as a shifting theorem as well. So the Laplace of t ut minus 3, the answer is e over 3s fs. But if fs is Laplace of ft, but ft is t plus 3, that's why it is different. So Laplace of t plus 3, Laplace of t is 1 over s squared, plus Laplace of 3 is 3 over s. So you substitute this inside this equation, fs, then you get this one. This is the final answer. E power minus 3s, 1 over s squared plus 3 over s. So the major trick is this one. Any question, class? Wong Chen? Any question? Example 9. Yeah, Muhammad Salman. Yeah. Muhammad Simon. So why the A in this question is not same? No. A is 3, same. No. Roger Wong. Sir, why the A in this equation is not same? Same. A equals to 3. Same. This A, you must make it 3. No, we have to make it 3. T minus 3. But this T minus 3, this one you want to make it. In the problem is T. Which previous question? Which question? Huh? Yeah, 2t minus 1. Yeah, the t minus 1. Same. That t minus 1. No, same. No. 2t minus 2 minus 1. Modify A. This one equals to 2. You didn't listen carefully. Yeah, you have to ask. Sorry. 2t minus 2 minus 1 equals to 2 t minus 1. This is the trickiest part, class. Watch this carefully, yeah? Like this, yeah. 2t minus 3 is 2t minus 2 minus 1. So you take out 2t minus 1. So the t minus 1 becomes t. Because t minus 1, you must make it t. So 2t minus 1. 2t minus 3. Yeah, 2t minus 3. 2t minus 3 equals to, modify 2t minus 2 minus 1. You must modify it. So equals to 2. You must make it t minus 1 as one term. And then minus 1 like this. 2t minus 2 minus 1. So the t minus 1, because the u is t minus 1. Okay, Venkan? Are you okay, Venkan? Venkan, are you there? Otherwise, you will get different answer. If you do Laplace of 2t minus Laplace of 3, you will get different answer. Because this one is the same. But the t, because this is the t minus 1 minus t minus 1 becomes t. That is the idea of transformation. So the t minus 1, later, the t minus 1 becomes t. Because this is ut minus 1. This is t minus 1. So they miss the step class. This one missing. The steps are missing from here to here. Missing. One step is missing. So you got to write this using this t minus 1. Okay, so we already finished this one. So the final answer is Laplace of ft, slide number 24. Laplace of ft 1 over s squared e minus e power 3s over s squared minus 3e minus 3s over s plus 2e power 3s over s. Of course, you can simplify this because this is s squared. So you can combine this to make it 1. And then these 2, you can combine it 1. So the next one is the important. This one is inverse of second translation theorem. So the second translation theorem, we use Fs Laplace of Ft. So Ft is inverse Laplace of Fs. So you all know this very well. Now, how do we use the inverse for the second translation theorem for this? So Laplace of Ft minus A ut minus A is E minus AS Fs. So inverse Laplace of E power minus AS Fs equals to Ft minus A ut minus A. So this is very famous formula. We want to use this formula to find inverse Laplace of 1 over s minus 4 e minus 2s. That means you are changing the s domain to t domain. So in this case, you see here, this EAS is ut minus a. Fs is the Laplace of t minus a. So you match this. This one equals to this. Your Fs is 1 over s minus 4. So this is A. So A is 2. All right. So A is 2. We already found A. So you have to match this with this. Your Fs is 1 over s minus 4. You look at the table. Go back to the table. This is very important class. Otherwise cannot. You refer to the 7 equation in table 3.1, slide number 18. The Laplace of e power 4t 1 over s minus a. So for the inverse Laplace, you have to check with inverse Laplace table number, that is inverse Laplace is 3.2. So chapter 3.2, you check under inverse Laplace. I'm referring to table number 5. Slide number 5, inverse transform. You see inverse transform, inverse Laplace 1 over s minus a is EAT. So a is 4. So the answer is E40. So inverse Laplace of 1s minus 4 is E40. Now, you want to write ft minus a, ut minus a. So, inverse Laplace of 1 over s minus 4, E40. This is ft. But your ft is E40. But what we want is ft minus 2. This is t minus 2. So, t minus 2, you just adjust. Replace the t with t minus 2. Because you have ut minus 2 here. So FTE40, this is how the shifting theorem works, class. There's another name for this. Of course, translation theorem is the title. You shift, the t becomes t minus 2 according to this formula. So ft minus 2, just simply remove this t with t minus 2, that's all. So it becomes e power 40 minus 8. But you no need to simplify, it's already factorized. So the final answer is inverse Laplace of 1 over s minus 4 e power 2s equals to e power 4 t minus 2 ut minus 2. Don't forget to write ut minus 2 because this comes from this formula. Any question here, class? Yeah, one can. Yong Wei, any question? Example 10. Yeah, Yong Wei, any questions? Wei Kan, any questions? Yeah, this is the last slide for the translation theorem. So anybody else? This is a question and answer session. So you can refer to all the previous slides. They're all free. So this translation theorem, we missed it last week. So to summarize this, if you go back to inverse Laplace, this comes under inverse Laplace, right? So there are a few questions here. Translation theorem, yeah. Later I will show you method of solution, some of the extra example, but the slides will not be uploaded. You have to take notes and then see. This translation theorem in a summary, I can summarize for you. So first translation theorem, Laplace of EATFT Fs minus A. That means you adjust this S with S minus A. But we don't have the formula for this. You just have to adjust. You already have the formula for Laplace. This we have 7 for Laplace transform and 7 for inverse Laplace transform. That's all we have. So Laplace of EAT equals to 1 over s minus a. Laplace of t power n factorial Sn plus 1. So this EAT-FT, you find Laplace of FT, but the S you replace with S minus A. That's all. So this is what we call translation theorem. We already done this. I just glanced through how you modify this. This one, Laplace of t power 3, 3 factorial s power 4. Your n is 3. But your s must be s minus 5. Because your a is, if you look at this formula, your a is 5. So this one, s minus 5. S becomes s minus 5, like that. So this is what we call translation theorem or shifting theorem. So here, cos. So the cos 40, you know the famous formula, Laplace of cos kt. You must refer to the table 3.1, slide number 18, transform of some basic function. So Laplace of cos 40 is well known, s over s squared plus cos squared 16. But since your a is 2 minus 2, so s minus a. S minus a is minus 2. So s minus minus 2, s plus 2. So s becomes s plus 2. That is shifting. You change the s to s plus 2. According to this formula. Okay. So inverse Laplace is the same. From Laplace, you take inverse Laplace of fs minus a, inverse Laplace fs, ss minus a is EAT-FT, is the same. So how do you do this? One thing is you must know the partial fraction. So the partial fraction is available in 3.2 table number, slide number 40. Under the inverse Laplace transform, this is still a major problem that you will face because you are not familiar with the inverse Laplace transform for the form of rational function and form of partial fraction. There are 2 columns table, 1 to 6 formulas. Start with px plus q divided by x minus a, x minus b. You must write a over x minus a plus b over x minus b. This is what we call partial fraction. Solving partial fraction falls under algebra. So one may ask, how do you get this? Please check, yeah? This is already done by using the formula number 2, 3.2, slide number 14. Take note, yeah? This one already done. So a over s minus 3 plus b over s minus 3 squared. Because this is px plus q. So you must find a and b, 2 and 11, using any method. It's up to you. That's why this part they already skipped, missing. Step is missing doesn't mean that there is no step. There is a step, but it is not shown here because you have to do it by any method. Any methods, meaning some can do it by intuitive. No calculation, no steps, no process. Just put the value 2 and 11. How to do that? That is your ability and your skill. But you may ask, how come 2 and 11? From where it comes? Of course, it is not falling from the sky. It doesn't fall from the sky. You have to do. But how to do? There are many ways. And this is the message class. We want to tell you, that 2 and 11 is not shown here. That doesn't mean that you have to show, because this may be a very short one step only, 2 steps, or maybe 5, 6 steps, 1 page, 2 pages. So one cannot argue here why you didn't show the ways. And in the next, after these slides, I will show you how they do it. But generally, we use the name partial fraction. But the partial fraction is the form FORM only. But how to find the A and B, that is, you have to do it. Once you break this into 2 pieces, then you can use the formula. This one straight away E3T. This one S squared, you use S squared is the T. But since S minus 3, your A is 3, E3T. Using this formula, this one, A is 3, S minus A. This is S minus 3. This one, many students ask me, how you got this? This one is the most trickiest one. It's not about the partial fraction. This is about this one, the roots of this equation is outside the real number. We say complex number because this is 11. You cannot factorize. So the partial fraction table doesn't work here. So how to do that? Watch this carefully, class. This is S. This is S plus, S, we don't know yet. This one, S squared, 6S plus 11. But this is already S. So if you look at the table, Laplace transform, if you look at the table, Laplace transform 3.1, right? If you look at the table 3.1, in the table, you see Laplace of cos kt. I'm giving you the hint, yeah, the tips. If you look at 3.1, transform of some basic function, Laplace of kt is equals to S over S squared plus K squared. So I already saw S here. And I already saw S squared here. So the final answer for S is about cos. But it is not directly S over S squared plus K squared, because this is S squared plus 6S plus 11. So what we have to do here, I already know we are moving towards the cos, but it can be cos plus other function also, because this is not directly cos. But in order to settle this case, S squared plus 6S plus 11, we have to use completing the square. Write down, yeah? Please write down this word. Completing the square. This is another term. Nothing to do with partial fraction. That is another way. Partial fraction only will work if you can factorize. So in this case, there is no real number S plus 2 multiplied by S plus 3. Cannot. So this term cannot be factorized. So therefore, we use completing the square. Completing the square meaning this 6S I can write as 3S plus 3S. 3S plus 3S. So if that is the case, I have to get 6S, 3S plus 3S. So if I make it S plus 3 squared, then I get S squared plus 6S plus 9. This is the trick, class. This is the trick how you modify this. So 6x already have, but there is another term, 3 square 9. So 9 plus what? 11, like that. This is how you have to work out. Think like this. 9 plus 2, 11. So you put 2 here. And we know that this part will go to cosine provided you have s plus 3. Because the denominator is s plus 3. In order to get the cos, using the translation theorem, this s must be s plus 3, otherwise cannot. So we start with the translation theorem, which leads to cosine. Because this one, EAT Laplace FT, Fs minus A, this one. So, you have to make s plus 3. If you put s plus 3, you must minus 3. You ask why minus 3? Because you modify this as s plus 3. Of course, you have to minus 3. Then back to s. You cannot put s plus 3. Of course, s plus 3 not equals to s. But s plus 3 minus 3, same as s. You are just modifying this only, class. But this one, you have to break into 2 pieces, like this. S plus 3 divided by s plus 3 squared plus 2 minus 3 over s plus 3 squared plus 2. All these just a manipulation on algebra. Nothing to do with Laplace yet. Because you want to find inverse Laplace, you are moving towards inverse Laplace. On the way, you go through this little bit kind of turbulence. Modifying, adjusting, completing the square. This is the knowledge. You must have this knowledge. Now, this one can go to cosine. And this one, you check the formula. Sine kt is k over s square plus k square. K over s square plus k square. So this must be k, and this must be k. S plus 3, you just use the translation theorem. But the answer is sine. This one confirm cos. So how do we do that? We do another manipulation. This one s plus 3 square plus 2. If you want to use cosine, this must be root 2 square. You modify this. So now, inverse of this, you can write this form, but s must be s plus 3. Because there is no formula, inverse formula for s plus 3. You only have inverse s over s square plus root 2 square. Of course, you can skip this step. So from here, answer you can write here, because your a is 3. So s minus 3. So a is minus 3. So you go back here, you check this formula. So s minus 3. So a is minus 3. Because this is here you have s plus 3. So e minus 3t cosine, but this must be root 2t, not 2t. Because this is 2. Check the formula. Formula says cosine cos kt s over s square plus k square. K square is 2. K is root 2, positive. So this part is clear. Now this one, still not completed yet. This 2, you must make it root 2. But this 3 must be put outside, because this one, you put 1 here, so that you must have root 2 here if you want to use the sine formula. You must know the final answer as well. Final answer means according to the table 3.1, slide number 18, Laplace of sine kt equals to k over s square plus k square. So this k squared is 2. K is root 2. So you must put root 2 here. At same time, you must divide by root 2. Otherwise, this is incorrect. So this is very important. So you put root 2 here and you divide root 2 here. So that means this is just like equals to 1. Now the final answer is minus 3 over root 2. A is minus 3 because S plus 3. So A is minus 3, e power minus 3 sine root 2t. So this is your final answer, inverse Laplace. Any question, class? When, Young, any question here? Because one student sent me a message asking how do you get this factorization? Yeah, this one. How do we do this one? Yeah. Yeah, Young, any question? Wei, Tam, any question? Tam, Tan, any question? Sumin, any question? Sumin? Any question, class? Yeah, waiting for you. Yeah, Mohammed, Fawaz. Yeah, Young, so far so good. No, sir. Clear, sir. Okay. Okay. Just you wait, huh? You just wait. I'm going to upload yeah, Nurul Shahira. Are you here? Nurul Shahira? Are you here, Nurul Shahira? Oh, you are here, not here. Okay. Nurul Shahira is not here, right? Are you here, Nurul Shahira? Nurul, are you here? Nurul Shahira is COE, right? He asked me a question about the unit step function. Okay. Okay, so okay, thanks. So many students ask about yeah, this one. So this one you have to study how to handle this. So make sure you know how to do this. So I hope you can go through this. Now I still have some time. So I want to show you another slide for solving the ODE. You just wait, yeah. Okay, this one we are not going to upload, will not be available. So just I want to show you some of the example differential equation, solving differential equation. So there is some shortcut how to solve the differential equation. I don't want to show you all the thing, but just to show you this example. Pay attention. Solve differential equation shown below. Okay, can you see the slide? Hello, can you see the slide? That's Muhammad Iskandar. I'm sorry, we don't have this slide. If you want, you can take a photo of this, take snapshot, because you already have the examples, but this is extra examples since we have time. So I'm just giving you this. So quick one, yeah? This is very short. dy dt plus 2y equals to 12. Actually, this is a linear first order differential equation with the initial condition. Why we need Laplace to solve this question? Yeah, why? Because if you solve using the integrating factor, it's very lengthy, and you always ended up with the constant c. So you must use this y0 equals to 10 as a initial condition to find the c. This is one of the extra job. So Laplace transform, you no need to find the c. If you notice carefully, there is no c in your final answer when you solve the differential equation. First order, second order, third order, and so on. So that is one of the advantage of using Laplace transform. So as usual, you take Laplace of dy dt plus 2 Laplace of y equals to Laplace of 12. This is step number 1. Laplace of dy t sys minus y0. So y0, they already substituted 10. Sometimes you can skip the steps class. No need to write everything. This is good for the engineering student, especially for you. Once you are very familiar with this, you can throw away all the steps. What we want is the final output. Your final output is correct, you get 10 over 10. Of course, there will be some steps, but no need to repeat A to Z. Okay? So Laplace of 12 is 12. Laplace of 1 is 1 over S. So this is your S domain. You can factorize. Take out ys, take out ys. So you have s plus 2 ys. This minus 10 goes to right hand side. 10 plus 2 over s. Now, this part, how to make it ys? Because you have to take inverse Laplace of ys to get yt. So yt, the t domain is your final output. Remember, yeah? What is the most important thing is in this question is your final output, yt. So here, ys is 10 over s plus 2, 12 over ss plus 2. But you may say, can I simplify this? If you look at the previous lecture notes, they simplify this, then you bring s plus 2. This is what we call the algebra. This one look like partial fraction, but still you have to simplify this because there is no inverse for s plus 2. Go back to the table again. Always remember, yeah, the table is very important. Without that, cannot. You must know the Laplace and then the inverse Laplace. Laplace and then the inverse Laplace. So inverse Laplace is 3.2. 3.2 inverse Laplace, you refer to the table. Table 3.2, number 5. So, how to handle this? This is a very powerful shortcut. This one is okay. This one, straight away, you can use formula number 3. EAT inverse Laplace 1 divided by s minus a. So, my a is minus 2. So e power minus 2t. So this one settled. But this one don't have the formula. So therefore, you use partial fraction. Partial fraction is not a method. It just decompose. This 12 divided by ss plus 2, a1 over s plus a2 over s plus 2. Now you see the most powerful shortcut methodology. How you find a1, a2. This a1 equals to s, this is s, yeah? This is s multiplied by 12 over s plus 2. You put s here, divided by this 12s plus 2. So this s cancel off, 12 divided by s plus 2. You substitute s with 0. When you substitute s with 0, 12 divided by 2, 6. This is one way how to find the a1. For a2, this is s plus 2. So you put s plus 2 here. But this s plus 2 cancel off, 12 over s. Substitute s with minus 2. You set s plus 2 equals 0. S is minus 2. So 12 divided by minus 2, minus 6. This is the trick class. This is something like intuitive method or shortcut method. So you have ys 10 over s plus 2. This one we already done. So 6 over s minus 6 over s plus 2. So 6 over s. This 10 minus 6, 4. 4 over s plus 2. 6 over s, inverse Laplace of 1 over s is t power 0. 1. So 6 multiply 1, 1. 6 plus 4. This s plus 2 inverse Laplace of 1 over s minus a. A is minus 2. So e power minus 2t. So this is your final answer. Can you get this, class? This is another way of doing a shortcut method. No need to use the long process, find a1, a2. factorize and then find the denominator, equate the coefficient, left-hand side, right-hand side, all you no need. Can you get it, this class? Hello? Ahmad Bakhtiar. Can what? What do you mean by can? So, but they are not going to repeat this method and again, yeah? So this method, how to find A1, A2, one example only. Later on, you have to do on your own. That's why sometimes they straight away write A1, 6, A2 minus 6. So how you found the value is up to you. 12 divided by S multiply S plus 2. You decompose like this using partial fraction, step number 1. How to find A1, A2, it's up to you. We can use many ways how to find A1, A2. But the A1 in this case 6, A2 minus 6, and your final answer must be like this. But you may say, why there is 3 terms here? But these two same. 10 OS plus 2 minus 6 OS plus 2 is 4 OS plus 2, same. So 10 minus 6 is 4. 4 OS plus 2. This one 6 OS. So final answer is only 2 terms. If you find 3 terms, still you can simplify. Yeah, Yao Kong. Yeah, Y-A-O. Yao Kong. Any question? Yao Kong? Thank you, Yao. Yeah. Yeah. This is an example just to let you know how to solve this ODE. Solving the ODE, this one, using Laplace transform. So the method is just few steps, but this one is the trickiest part plus. So if you look at another example, I don't want to take your time more. You see this example, dy dt plus 2y equals to 12 sine 40. They ask you to solve using Laplace transform. Okay, so y0 is 10, initial condition given. See, they already skipped Laplace of dy dt straight away sys minus y0, put 10 here, plus 2 Laplace of y, ys, 12, Laplace of sine 40 is 4 os square plus 16, because this k is 4. So sine k square 16, you must put 4 here. So 12 multiply 4, 48. This one you factorize. 2 s plus 2. So minus 10 become 10. See how fast they move, very fast. They skip all the steps. So ys 10 over s plus 2, 48 s plus 2, s square plus 16. This one no problem. 10 over s plus 2. You already have answer, inverse Laplace 1 over s minus a is EAT. So my a is minus 2. But this one is the problem now. This one, 48 over s plus 2, s square plus 16. You cannot factorize this. You must take note, because there are 16 formulas, right? So inverse Laplace, 6 formulas, not 16, 6 formulas. This one is the formula number 6. Formula number 6. Even there is no s up here, but this is power 1. So still it falls under formula number 6. A over s plus 2. Because this one cannot be factorized. That's why you have B1S plus B. This one cannot be factorized, means there is no real number roots. S squared plus 4 cannot. S squared plus 4 power 4. No. There is no way you can simplify this in real number. So now you want to find what is A. What is B1? What is B2? Sometimes you use ABC, but here very nice, because this one within this. So they use B1, B2. So how to find? You see here the shortcut. So the A for A, this is S plus 2. So S plus 2 divided by S plus 2, 48 over S squared plus 16, this one. So this is to find your A. S plus 2 divided by S plus 2, S plus 2 divided by S plus 2, left with 48 over S squared plus 16. There is a way how to do this. So you substitute S plus 2 is 0. So S minus 2. So S minus 2 minus 2 squared is 4. 4 plus 16, 20. So 48 divided by 20 is 2.4. They put in terms of decimal number, but this is correct. Once you have 2.4, you can put this A here, no problem. Now you want to find B1 and B2. So you substitute this one as 0. S0, just substitute S0. Anything. The simple one is S0. When you substitute S0, this whole thing class become 48. 0 plus 2, 2. 0 plus 16, 16. Equals to 2.4 divided by 0 plus 2, 2. Plus S is 0. So no B1. B2 over 16. So you solve this, you find B2 4.8. Now, B2 you already found. Now you want to find B1. Just now I put S0, so the B1 disappeared. Now we put S minus 1, that is the nearest one. You may say why you put minus 1? It's just as simple as that. Just put any value as you like. The easiest one is minus 1. So 48 divided by S, I put minus 1. 2 minus 1, 1. Minus 1 squared plus 16, 17 equals to 2.4 divided by S minus 1. Minus 1 plus 2, 1. Plus B1, S minus 1. Minus B1 plus B2 divided by minus 1 squared. Minus 1 squared. 1 plus 16, 17. You solve this. B2 4.8. Therefore, you solve this, your B1 will be minus 2.4. This is very nice, interesting method. This is what we call the interesting part of solving the algebra. Actually, you are using algebra here. So, A found already, B1, B2 already found. Now, you put everything is here. So, these two are same class. Okay, these two are same. 10 plus 2.4, 12.4. E power 40. E power minus 2t, because your A is minus 2. The formula says S minus minus 2. Now, this one is S squared plus 16 is cos. Minus 2.4 is here. 14, 16 you must write 4 squared. The formula says K squared. K squared is 16. So K is 4. So therefore cos 40. This one, sine squared plus 16. You must have 4 here. But there is no 4 here. Because K squared is 4, sine 40. So you divide 4.8 by 4. So you get 1.2. You see, they already done. So this is your final answer. Any question, class? Interesting problem. Ahmad Bakhtiar. Muhammad Iskandar. Muhammad Fawaz. Any question? Yeah, any question, class? Sir, why initially S is -2? What do you mean by this? I cannot get it. Why? Yeah, because this you miss this method. Yeah, here. You see here, this one S plus 2. So S minus 2. This one. Follow this. So why initially, Roger Wong, why initially S minus 2? Which one? This one. Because, yeah, because this is S plus 2. So, you see here, this is S plus 2, cancel off. So, here, S plus 2, 0. So, S is minus 2. So, minus 2 squared, 4. Yes. Yeah, tricky class. Yeah, this is the trick. This one, S plus 2. This is S plus 2. S plus 2. You want to find A. So 48 over S squared plus 16. So you set S minus 2 because this, if you set S plus 2 equals to 0, S become minus 2. Of course, you don't put 0. You use that to calculate the A. The A is 48, this 48 divided by S squared plus 16. Similarly, the next one, 48 S plus 2 S squared plus 16, they're using different method. They change. Now this one is different, change. But this B1 S B2 still the same here. And this one same. So this one same. But A already found. Quickly they found A. This is another way of doing. So you have to learn this new technique. So you find A, put here already, A already done. Now B1, B2 is up to you how to do it. This is the shortcut. How to do this is up to you. We just simply substitute S0 and here S minus 1. You create these two equations and solve B2, B1. Only thing is it must satisfy the left hand side and the right hand side. So you solve. But you already know B2 here. You just plug in the B2 here and then find B1. This is very easy. If you use a calculator, you just plug in, and then you get this very nice, beautiful answer like this. This is ys domain, and then inverse Laplace yt. They don't write. What they want is this yt only, the final one. These two combined, yeah? You no need to, if you write, it's okay. If you write separately, it's okay, but it is combined. Okay, the last one is this one. Oh, no more already. Yeah. Yeah. This one, class. Yeah, this one. Very interesting one, class. Very powerful. Yeah. So this is the last one. At least you must know the maximum order is second order. D squared y dt squared plus 3 dy dt plus 2y equals 24. Y naught is 10, y dash naught is 0. Initial condition. Two conditions must be there because this is second order. You know second order, this is s squared ys minus 10. This is y naught s minus y dash 0. So y dash 0 goes here. This 10 goes here. Plus 3 sys minus y naught. This goes here, 10. Plus 2 ys, Laplace of y, ys. 24, Laplace of 1, 1 os. So you simplify this ys, take out ys, ys. So there are three terms. S squared plus 3s plus 2. So 24 over s squared plus 3s plus 2. And this 10s plus minus 10s becomes 10s. 3 multiply minus 10, 30. So 10 minus 10s, 10s positive. This is plus 30 divided by s squared plus 3s plus 2. Just now this is 24 over s. So this one, 24s. This s squared plus 3s plus 2 comes from left hand side. They already skipped many steps, class. So it's not important. All the steps are not important. So the main thing is how far you can get the yt. So this one, class, interesting. Yeah? S squared plus 3s plus 2 you can factorize. S plus 1, s plus 2. Here plus 10s plus 30, s plus 1, s plus 2. Now, how you want to use partial fraction? So partial fraction, this one is already done. So it is your job how to do this. So 24, a over s. So they are doing this one first. This one first. Okay. So 24, s plus 1, s plus 2, a, b, c. A over s, b over s plus 1, c over s plus 2. If you take s, so you set s0, so 0, s0, 0, 2, right? So I set the s here is here, s, in order to find a. In order to find my a, actually this is a. So s, then I set s0, 1 multiply 2, 2. 24 divided by 2, 12. See, already got. This is what we call intuitive knowledge. Very powerful. No method, no steps, no process, no any procedure or no ways. Direct find 12. And B, this one for s plus 1, if I substitute s plus 1, s plus 1, if I take, this is s, I cannot take s0. If I take s, S plus 1, S minus 1. So I take S minus 1, this is minus 1, this is minus 1. So I have 2 minus 1, 1. Left with S plus 1. I got minus 1 here. So minus 24. So I already got this. The last one, S plus 2. So S plus 2, S plus 2. Left with S plus 1. So I take S minus 2. So minus 2. Here minus 2. Minus 2 plus 1. Minus 1. Minus 1. Minus 2, 2. So 12. 24 divided by 2, 12. You see, very powerful. So similarly, 30, 10s plus 30, this one, this part. Sorry, no, sorry, different, yeah, sorry. This one, 10s plus 30, s plus 1, s plus 2. You have A, S plus 1, B, S plus 2. This is a partial fraction, but how to get A and B? So first 10S over S plus 1, S plus 2. So you take S plus 2. Take out S plus 2, S plus 2. S is minus 2. So minus 2, sorry, S plus 2, S plus 2, S minus 2. So minus 2 plus 1 minus 1. So this is minus 2. So 20. And then 30, S plus 1, S plus 2. You want S plus 2. So S plus 1. So S minus 1. So minus 1 plus 2 minus 10. So you already got 10. Here 20. Now your Fs, this plus this, right? So 12 over S, this one comes here. And this one minus 24 plus 20 minus 4, S plus 1. So these two combine, you get this. This one combine this, 12 minus 10, 2, S plus 2. But this one, inverse Laplace. Now you want to find Yt, that is Ft, yeah? So inverse Laplace of 1 over S is 1. So 12 minus 4, inverse Laplace 1 over S minus 1, E minus T, plus 2, inverse Laplace 1 over S plus 2, S minus 2, E power 2T. So this is last example. But if you have any question here, you can ask me before we finish this session. I think another 4 more slides to go. But do you have any question here, class? Any question, class? Yes, for Maria. Yeah, regarding the quiz 2, quiz 1 still, we will send you email. You can do it via email and submit the quiz answers via email quiz. The assignment we are trying via online assignment if you cannot make it by Saturday or Friday, we will postpone it next Monday. But we are trying via ULearn. So any information you refer to ULearn. Okay. So we have another example here, but I'm not going to into detail because it is the same second order. So we already finished this one. So that's all for today. Any questions? Thanks for the quiz 1. We already have the marks for quiz 1. We will try to upload. We'll inform you. But at the moment, we are in the preparation of assignment, at least one assignment. We are not sure whether it will be ready by this Saturday or not. But in any case, worst come worst, next week, Monday or Tuesday. So any question, class, before we stop? You must fill up, please, fill up the satisfaction form. Satisfaction form in the new, and then SSRP, fill up in the new campus, please, yeah, because we have problem here. We need at least no need to submit. No need, just discussion only. Discussion with your satisfaction 4. We need at least greater than 70, yeah. Example 16. This one. You mean this one? Mohammed Fawaz. Example 16. Okay. You take down this. You take down this. You can copy this. D square y dt square plus 2 dy dt plus y equals 20. And then y0, 0, y dash 0, 0. Find the Laplace of s square ys, y0, y dash 0, 10 plus 2 sys minus y0, 0 plus 5 ys, 20 inverse Laplace 1 os, and then 20. This one ys, this one the minus 10, yeah. This one minus 10 become 10, and then 20 is here, and then 5 2s s squared. So this s this s 20 s squared plus 2s plus 5. This is 10. This 10 become here s squared 2s plus 5. Here you have to be careful how to factorize this. So this one s plus 1 squared plus 4. This is the trick. But that will later. But this one 20 over s squared plus 2s plus 5. You do one by one, yeah, this part first. Okay, how to tackle this and then move this. This is a strategy. Okay, 20 s squared 2s plus 5 A or S, because this is S squared, cannot be factorized. Factorized means it's not like S plus 2, S plus 5. So that's why this is AS plus B. Because this is S squared, there is no S here. So AS plus B. Now to find S, this one they already found, this 4. This 4 they already find already. S0. This SS, so S0, 0, 0, 20 divided by 5, 4 already. So no need to find this, 4S already. AS plus B, just substitute S equals to 1. So 1, 1, 2, 5, very interesting, yeah? So 1, A plus B, 1, 1, 5. So this one equation. And S minus 1, very interesting. Here, S1. Substitute. This 4 is there. So S minus 1. So minus 1 squared, minus 2 plus 5, and then 4 minus 1. This is minus 1A plus B, minus 1 squared, 2 minus 1 plus 5. So you solve this, your A is minus 4, B is minus 8. So you put inside here. So this 4S and then minus 4S minus 8, S squared 2S plus 5. And this one is the same. This one, same. So 10 minus 8 is 2. So we already simplify this. This is the final form. Because this is same. Minus 4S is there. So now the problem is this S squared plus 2S plus 5 cannot factorize. Use completing the square. Now they show you the way how. S squared plus 2S plus 1, 5 minus 1. Because you plus 1 here. Why? Because you can write S plus 1 squared. This is called completing the square. S plus 1 squared is S squared plus 2S plus 1. So you must minus 1. So 5 minus 1, 4. 4 is 2 squared. So this one you can write S plus 1 squared plus 2 squared. But this is minus 4S. This is S plus 1 plus. Watch this carefully, very tricky. This minus 4S. But this is S plus 1. So I must minus 4 because I want to put S plus 1 here so that this same as this. So I put minus 4S minus 4. So therefore I take out minus 4. But I put minus 4 here. Here 2. So I must plus 6. So I put it here because this formula will go to cos. This formula will go to sin. That is the trick. So this one 4S is 4. This is minus 4. The S A is minus 1t. This is cosine 2t. And this is 2 squared. Because this is 2 squared. And this one, you see, this is 6. Just now I said 6 minus 4, 2. But the 6 you write 3 multiplied 2 because this is 2. So here 3 is outside. And then e power, this is S plus 1. My A is minus 1t. And this one 2 sine 2t. So this is your final answer. Yt equals to 4 minus 4e minus t cos 2t plus 3e minus t sine 2t. This is the last slide, class. Muhammad Fawaz, are you okay? Muhammad Fawaz. Clear, sir. Thank you, sir. This is called the powerful shortcut. to learn this technique class. This is something new. I just got it last minute. You can search this, some websites available. They explain all the steps, but sometimes they skip it because you already knew. They are not repeating all the steps, but here they cut short here and there. But most important thing is what? Most important thing is what? This one. This one. Even you made mistake in your constant ABC, but if you have cos 2t, sine 2t, and e power minus t, e power minus t, you are okay. Of course, this is 4s is special. Inverse Laplace 1 over s is 1. Any question, class? Before we stop. Any questions? So please fill up your satisfaction poll, yeah? So we stop here. Yeah. So that's all for today class. Please revise for your test 1, maybe coming soon, but I'm not sure. For test 1, you have to consult with the coordinator. Dr. Mohana is there. You can find out from Dr. Mohana when is your test 1. Yeah. So I have no idea at the moment. Tan is here. Tan. So if you want, you can consult or you can email to Dr. Mohana. Suniljit Singh, are you there, Suniljit? Suniljit Singh, are you okay? Suniljit Singh, yes sir, all good. Thanks. Thanks, Suniljit Singh. Natasha, okay. All right. Okay, class. So thanks for your time, and then see you in the next lecture. You can take the snapshot of this. Very interesting problem, full of tricks. You take down this, not available via ULEarn, but you can take the picture of this. Take the picture of this and go back and try. To solve. It's a good practice. This is a wonderful example. How we do it in a shortcut way, a very smart way, quite intelligent approach. So if you want quickie, a fast one, but good one. Fast but good. What we want is the output.
So we browse through, as I said,
this is what we are very thirst for. But even your output is wrong, but your method is
so after that we have
reasonably okay.
I am just going to browsing
no need to
previous topic.
You try, of course, you try your
remember